Welcome, everyone. We're excited for you to join us for a power lunch with let's say, a mixed team with the Evoqua team as well. We're happy to be joined by a couple of key partners. First and foremost is Frontier and UCC. But what we want to do, and just given the tight timeline, we want to jump right into it, is talk about the latest relative to the EPA guidelines for effluent limitations, ELGs, let's say. I am Patrick Regan, the power leader for Evoqua Water Technologies. I've got a handful of subject matter experts that will be going through and hearing different aspects of the rule. First, we have Chuck McCloskey and Max Swoboda, both business development leaders for Evoqua, as well. Tim Pickett, many of you know Tim and probably know him well. He's CTO and co-founder of Frontier Water Systems. And rounding out the group is Kevin McDonough from UCC, who leads their sales and marketing organization. But with that, just one quick housekeeping piece. As the announcer called out, everyone is on a muted line. We have let's say, a very healthy audience today, which we're excited about. But ultimately, if you do have a question, as opposed to trying to unmute lines and having some painful echoes associated with that, I would suggest you use the chat feature, which you should see. It depends on how you have it set up on your screen, but you should see to the right of your screen. We will be watching that regularly during the session to really capture any questions that we'll save towards the end for a brief Q&A. So with that, hopefully you can all see my screen. But as I mentioned, we're here to talk about the final rule. And this is really about the EPA's actions at the end of July around CCR to a degree, but really more focused on the action at the end of August, which is ultimately a submission of a final rule to the Federal Register for formal publication. But in that, it really is finally providing some clarity into the two elements that were highlighted in 2017 for reconsideration, really an addendum reconsideration of the 2015 ELGs. Just to call out some of the particulars, if it's not obvious, right? This is not intended to be legal interpretation or site-specific regulatory guidance. This is, let's say, I would consider very educated insight from a set of subject matter experts who certainly have an opinion in talking to end users like many of yourselves, but also digging through the document. The intent here is to provide insight to the audience, but I would also say is intended to act as a catalyst for more engaged conversation, whether that be site-specific or more across a broader market segment. So with that, that's enough for me. Chuck and Max, if you can take us on and get into some of the details.
Thanks, Patrick. Well, if you're like me, when the rule hit the streets, you scrolled ahead to find the table with the effluent limit values. And here's a table comparing the water quality standards published in the 2020 rule to the proposed limits from 2019 and 2015. The variances from the proposed rule are modest and incremental, and most likely would not change the level of treatment required to meet compliance. What was more interesting was the inclusion of a new column labeled long-term average to meet compliance. That the EPA recommended designing to that level in order to make sure utilities consistently meet the daily max and monthly average values. Note that this long-term average is 30 to 60% below the monthly average published, depending on the constituent. We've already seen this approach being adopted by a major project that is underway. Finally, the timing did not change significantly. Implementation to begin 1 year after publication and no later than 2025. A significant change in the rule is the definition of what constitutes a low utilization boiler. The EPA modified the standard from an output value to a capacity rating. The EPA went on to estimate that this would change the viewpoint for 66% of the utilities who are planning to use this exemption. The rule maintains the exception for very high flow systems, although there are very few of those, and those that have committed to retirement by 2028. We confirmed the option for adopting tighter standards as part of the voluntary incentive program, based again upon the adoption of membrane-based technologies. The next table, the one on the left, shows the relaxed standards for those who qualify for the high flow and low utilization exceptions. Significantly, selenium and nitrate are not regulated under these conditions. The table on the right shows the tighter standards for those intending to go with the voluntary incentive program, including lower limits for all constituents and the addition of bromide and TDS. While maintaining the recommendation to use membrane-based technologies, the EPA commented, while there are many pilots underway, there is not a full-scale system operating in the US at this time. An additional comment was that more development is needed to handle the brine waste generated by this approach. Now I would like to turn it over to our colleague, Kevin McDonough from United Conveyor Corporations, to discuss the rule's impact on bottom ash transport water.
Chuck, can you hear me?
Yes, we can.
Okay. I'm going to jump into this, and we're just having a few connectivity issues, but we'll roll from here. All right. Thanks, Chuck. Appreciate it. Thanks, everybody, for joining us today. One of the things that we wanted to touch on was just showing the intent of the EPA to have some harmonization between the coal combustion residual rules and the effluent limitation guidelines, specifically as they pertain to bottom ash transport water. So one comment I want to make is the urgency, some of the urgency that's noted about that new cease receipt of waste deadline of April 11th, 2021 for formerly clay-lined or unlined impoundments. As those of you that are with us and understand what the timeframes are typically for these projects, to complete a wet-to-dry conversion project in 6 months is borderline impossible, if not impossible. But obviously there is an application for extension for a longer time period that reaches out to 2023 or 2024. So that being said, it goes into the ELG, which is also expressing some urgency of as soon as possible, but not later than December of 25. And obviously a lot of those details are going to have to be worked out with the permitting authorities. Typical timeline for bottom ash wet to dry conversion projects is commonly in the range of, on the short end, 12 to 18 months, and then could go in the 24 to 30 months with a more complex plant with multiple units and a more complex system. So with that in mind, wanted to touch on just a few points on the ELG, some changes that were made with that. Now the BAT conclusion is indicating high recycle rate systems. That's a change from high recycle rate plus dry or dry in the previous proposed revisions. They've made the basis high recycle rate. It doesn't preclude dry solutions. It just says their conclusion for the BAT from a cost benefit analysis standpoint is the high recycle rate systems. A key point about that is in that they are allowing provisions for blowdown, and you can blow down bottom ash transport water up to 10% of the system volume per day. But one of the key points, and I noted that in some of the notes that you're seeing on this slide, is that the permitting authority will assist in determining, quote, if and when needed, and the correct acceptable level. So it doesn't say you get automatically up to 10%. It's you're going to have to work with your permitting authority to determine if it's needed and what the level is. So I think that's an important distinction in these final ELG rules. On the low utilization boilers, the BAT conclusion is surface impoundments and the BMP plan. So the owner is going to be required to develop a BMP plan, even with low utilization boilers, that minimizes the discharge of pollutants by recycling as much of that bottom ash transport water as practical back to the bottom ash handling system. So I think that's an important distinction as well. While it's not a BAT conclusion of high recycle rate, there is an expectation of some recirculation of that bottom ash transport water. And of course, in the last group, the boiler's retiring by 2028, you can continue to use your surface impoundments, provided your surface impoundments are in compliance with the CCR rule. So switching over to some of the solutions, and I won't go into too many details on this on the next slide, but as most of the individuals that have done work or are familiar with or have gotten into the preliminary phases of bottom ash projects, we have a number of options for bottom ash transport water wet to dry conversions, which would provide for CCR and ELG compliance. About 75% of the fleet is done, pretty close to that, and I think the EPA stated that in the final ELG, and that's consistent with our record. So there's a fair amount that's been done, a large amount, and then a lot of operating references, but still a fair amount to do. So we've just listed some options here that I think many people are familiar with: the submerged flight conveyor, which is an under unit drag chain conveyor; the high recycle rate, which is a recirculation system with provisions for blowdown. Of course, high recycle rate can be remote SFCs, dewatering bins, or even concrete basins, where we can recirculate most of the water, that high recycle rate, but again, include provisions in there to slow down up to that 10% of the bottom ash transport water. The clarifying hydraulic system is a variation on the theme, which polishes the water a little bit more cleanly than a typical recirc system. In particular, we can do clarification down to 100 ppm TSS daily maximum, 30 ppm 30-day rolling average, which is consistent with most NPDES discharge permits. And of course, the last options are dry pneumatic or mechanical. One thing I wanted to touch on was our latest offering is our mobile max system, which is a hybrid of some of the SFC and high recycle rate system options that we've done in the past, but it's mobile. And of course, the primary motivation for us looking into this was, first, how do we reduce lead time? Understanding there might be some urgency, as I mentioned earlier, about complying with the CCR rule, getting off the pond quickly, converting the systems from wet to dry. So how can we cut lead time? Obviously, with a mobile system, it's a reduced installation time frame. So we're not setting permanent foundations. We're not doing as much temporary or permanent piping. We don't have as much pipe bridges and things like that. We potentially could even operate it manually, such that it wouldn't require DCS integration tie-in, or it wouldn't require permanent power. So the premise of the mobile max system is a remotely located submerged flight conveyor, which effectively dewaters your bottom ash and takes out a significant portion of the suspended solid. And then we take the overflow from the SFC to a clarifier. You guys are familiar with Evoqua's COMAG technologies, their mobile clarifiers. They have a lot of proven technologies in this area. So we would couple the UCC SFC technologies with proven Evoqua clarifier technologies to get a full system. And then that water can either be discharged, it can be recirced. The plant has a lot of flexibility, FGD makeup potentially. In addition, that system could potentially be used to do outage wash wastewater treatment as well. So it's another option that not only reduces lead time, but it also significantly reduces cost, as you might expect, because the installation costs are much lower for the mobile system than a permanent system. So that's just a very high-level summary of potential solutions for compliance. One size does not fit all, and that's why we've worked with our utility partners to come up with the right solution, and that's the way we would approach the balance of bottom ash transport water projects that are yet to be completed. So with that, I'm going to turn it over to Tim Pickett, who is the CTO and co-founder of Frontier Water Systems, to pick it up from here. Tim.
Thank you, and thanks to all for joining us. I'll be discussing the treatment technology basis behind the ELGs for FGD treatment. Next slide, please. The effluent limitation guidelines for FGD treatment are based on multiple water treatment systems working in concert. For most coal-fired power stations, this means physical chemical treatment followed by biological treatment with fixed film bioreactors and polishing with ultrafiltration. Most utilities with wet FGD scrubbers already have physical chemical treatment in place. If not, we can help or provide guidance on upgrades towards ELG compliance. What's new for most utilities is the integration of fixed film reductive bioreactors and ultrafiltration to meet the new limits in regards to nitrate, selenium, and mercury. Next slide, please. There are new advances in bioreactor technologies which allow for a smaller footprint than previous approaches. One example is our Frontier Seahawk system, which is a modular two-stage system consisting of an expanded bed bioreactor connected to a high-rate biofilter. On the diagram on the left, you see the expanded bed bioreactors are the circular tanks, and then the biofilters are the rectangular tanks here. This approach allows for off-site fabrication and drastically reduces installation and construction costs. The small footprint also allows for housing the treatment plant in a building, which is an important consideration for colder climates. Next slide, please. A complete ELG treatment system requires ultrafiltration as a final step to remove colloidal particulates that are precipitated in the upstream processes. UF integration needs to be done properly to work in this environment, and Frontier has pioneered this application. Again, it is the combination of a well-run physical chemical units with biological and UF that are required to meet the ELGs. In fact, the numeric values in the ELG limits are based on this complete treatment scenario. Next slide, please. We're pretty busy these days with proposals, and we'd like to engage any utilities in helping them understand their compliance options. So what we need for that is just basically it helps with kickoff phone call and some communication, around water chemistry, flow balance, utilization factor, and what the existing treatment units there, what phys-chem units are on site, and of course the compliance schedule. So with that, in about, right now we like to have about 30 days time, but we can furnish a pilot test plan. We don't always need a pilot. We often recommend it, but if we're comfortable with the water chemistry, we may skip that, compress the timeline. But we'll have a budgetary proposal with equipment costs for the bio and UF, a detailed scope of work, and GA drawings and a process flow diagram of the system. So you get a good idea of what it's going to take economically as far as to comply with the ELGs. Next slide, please. So based on the compliance schedules laid out by the EPA, timing is critical to execute a treatment plan for both CCR and ELG treatment. For most FGD treatment systems, we are currently seeing a 24 to 36 month project cycle, and timelines may stretch at peak demand. So time is of the essence here with everybody. I'll pass this over to Max to discuss the nearest deadline, which is coming up as soon as next April.
Yeah, thanks, Tim. The April 11th, 2021 deadline is connected to unlined surface impoundments. So on July 29th, the CCR rule change affected the classification of the impoundments with clay liners, moving them into the unlined clay, unlined category. Therefore, these ponds are subject to this closure deadline. If your plant needs to divert a low volume wastewater from an impoundment subject to closure, Evoqua can help with that. So let's now look a little closer at that timeline. So here's a hypothetical expanded timeline for a project starting with today. Meeting the compliance timeline for these projects is achieved using mobile and modular fleet assets. Since many plants may share the same deadline, the availability of those assets could become constrained. With early engagement on scope development, there is time to construct new fleet assets for a low volume system. The systems can be temporary and used as a transition to a permanent treatment system or as a semi-permanent system until plant retirement. Evoqua has completed similar projects with shorter timetables for customers that had other regulatory compliance deadlines. With over 40 executed projects related to CCR regulations, we stand ready to help you with your compliance challenges. Now I'll let Patrick take it over for any questions that you might have.
I appreciate it, Max, and everyone for that matter. Get my cursor to work here. So listen, this is, it's power lunch, right? So it's a pretty tight window. I know we're all busy, even working virtually, remotely. As I mentioned, the goal here is to provide an overview, right? And as I mentioned, is to go deeper, to act as a catalyst for deeper conversations, right? So what I've got on the screen here are all of our presenters' contact information. You know, as Tim and others mentioned, that we're here to help, and we'd be thrilled to set up a brief conversation to help understand what's your given scenario, and what role we may be able to play. And that might be a Frontier role, that might be an Evoqua role, that might be a UCC role, that could be all the above. But with that, I've got about 8 or so minutes left on the clock. And so what I wanted to do was use that time to answer some questions. So Mike, I will look for you to keep me honest of anything new that's coming in, but I've got a couple questions that are already teed up. And I think the first one here is relative to the biological system. So Tim, I'll steer it towards you. You look at the carbon source options necessary to keep that biological population happy. What are the options needed? One is a Frontier approach, and is anyone who puts in a Frontier system, are they married to that carbon source that Frontier is providing?
Yeah, that's a good question. We do have to feed a carbon source. There's no carbon source native in FGD blowdown. There's a variety of carbon sources that will work, from carbohydrates or sugar blends to acetic acid to even methanol. Our preferred carbon source is glycerin. We are one supplier of that. There are many others. Our glycerin is unique, so we do filter it down to 1 micron, so it does help prevent plugging in the distribution, the nutrient distribution system and such. So, but we're agnostic to the carbon source. Like I said, many others will work. Glycerin is a good balance between safety and cost. Of course, they're all commodities, so economics can change. But for the last decade or so, glycerin's been right in the money as far as cost goes, and it's readily available, and more so because it's a byproduct of biodiesel, which is a growing market in itself.
Okay, thanks, Tim. The next question I have here, I think we covered this a little bit, but it's worth going back to, and Max, it really kind of speaks to this timeline. But if I have a need for dewatering at an ash pond, what's my expected turnaround time to have assets on the ground? I don't know, Max, can you speak to that one?
Yeah, you got me?
Yeah, we got you.
Okay, so all sizes and shapes of systems are different, but normal installation to startup of this system is about a month. So you can work backwards from that to delivery schedule and equipment availability. So if the assets are readily available, delivery can be almost immediate, and then work from there. So larger projects that have higher flow rates, and I would say that's north of 2,000 GPM, where you're going to need multiple assets. Of course, the larger the system, the longer it would take. But a 3 to 4 month window from start to finish is achievable.
Okay, thanks, Max. Just a few more. Want to get as many of these as we can before we hit the bottom of the hour. But the next one I have here, Kevin, I think this is yours. We look at the Mobile Max system. What out of that this configuration you laid out, what's going to go indoors?
So the thought process there is almost none of that is going to go indoors. You would find a place where you would intercept the bottom ash sluice lines that are currently going to the surface impoundment, roll that equipment in, intercept those lines, redirect the water. That being said, if the plant does have, we do have a couple of proposals that we're working on right now where the plant does have some indoor storage warehouse space, and we're actually going to move some of this equipment into that unused warehouse space. But the expectation for the most part is that most of this is just going to be rolled out into the open. Interconnecting piping would be put in place, and then you would do your appropriate power connections and chemical feed injections, etc. For sure, for those plants that are in northern climates and have some freeze risks, we definitely would have some freeze protection that would be part of these systems. A big part of that freeze protection is the recirculating water that keeps moving from the systems. And then for certain things like the SFC head and tail sections, we might incorporate local heaters just to make sure that we don't get ice buildup on the SFC, as well as some of the other equipment.
Okay. Thanks, Kevin.
Mm-hmm.
Next question here is, it's similar to, I think, the question that Max, you answered around the ash ponds, but in short, Tim, this is for you. For the biological system, once those units, the assets are on the ground, what's my expected startup time? And I think this is really rooted in the fact that it's a biological system, right? So how particular are those bugs from your experience?
We schedule about 60 days from wet testing. That's typically, of course, there's a lot of things that can impact that, the construction schedule and it. But once the system's wet tested and water's flowing and everything's checked out, all the sequences are checked out, it's working hydraulically, we allow for 60 days. We can see results shorter than that. Okay. That's what we schedule.
And then one more, and then we'll do a final sweep of the chat here. But what kind of redundancy do you recommend, or even have you seen at various installations that you've done?
We've done up to 100%, but N+1 is typical. So one redundant train.
Okay. Okay. Just do one more check here. I've got 1228. Okay. I think we are good. Well, hey, team, I don't want to take up any more of your time, but as I mentioned, this was not intended to be a full comprehensive kit on everything you would ever want to know about ELG regulations. But given the time frame, this is an overview, and to some degree, this is a good to see you again with a Tim Pickett or a Chuck McCloskey. Or I would say, if you don't know these individuals across the board, these are certainly, between Chuck, Max, Tim, and Kevin, these are subject matter experts who are very eager to answer any questions you may have offline. So again, here's their contact information, email, and I think I put these guys, these are all your cell phone numbers. So I'll ask the audience to be kind, use sparingly, but the reality is, I think every one of us on this screen right now, we wake up every morning thinking about power, and are truly empathetic to the challenge that many of the power producers out there are facing. And we're looking to leverage our experience as best we can. So with that, I have 12:30 East Coast time, so that's all. And I look forward to hearing from many of you again here soon. Thanks for the time.
Thanks.
Thank you.
Thank you.